In this video, we are going to look at molecular shapes. So all of the Lewis structures that we've drawn so far are just drawn in the plane of the paper in the 2D, but they have three-dimensional shapes. So in order to look at this, we need to understand VSEPR theory. Now, VSEPR theory is valence shell electron pair repulsion theory. And we get Vesper by just taking the first letter from valence shell electron pair repulsion theory. Now, this is a lot of words, and that is kind of a mouthful. So, valence shell, that just means the electrons in that outer energy level. Those are the electrons that are responsible for bonding right there. Pair repulsion, all that means is electrons are negative. They don't want to be close to each other. So Vesper is just a way of talking about how electrons are going to repel and they want to be as far apart from each other as possible. So this behavior allows us to predict the shape of different molecules. We have two important components to Vesper theory. We have the electron pair geometry, which we will abbreviate as EPG. And this is just the location of all of the valence electrons. You're looking at lone pairs plus the bonding electrons. So we're looking at all of the electrons. The molecular geometry, which we will abbreviate Mg, is the location of the atoms within that molecule. So, and this is in the 3D. To determine the electron geometry and molecular geometry, we can use these steps. This table right here is for determining the electron pair geometry. And you will always be provided this table on one of your quizzes. So you don't need to memorize it. However, you do need to know how to use it. So this is only for determining the electron pair geometry. And when you're determining the electron pair geometry, you need to count all of the electron groups that are around your atom. So in order to do that, you have to draw your Lewis structure. So the first thing you're going to do is draw your Lewis structure and then determine how many regions of electron density surround that atom. What I like to do is just look at the sides of the atom. How many sides of the atom are taken up? Where I see a lot of mistakes is a single bond is an electron region, but a double bond is also just one electron region. So don't count that as two. And then we determine the electron geometry. If you have two regions, it's going to be linear. Three is trigonal planar, and four is tetrahedral. So these are the words that you need to be familiar with. If it is linear, the bond angle is 180. Trigonal planar, the bond angle is 120. And tetrahedral, the bond angle is 109.5. This is a big difference between the Lewis structures we drew with four things around the central atom. In the 2D, it looks like the bond angles are 90 degrees, and that's not the case. When you are determining the electron pair geometry, you can then determine the molecular geometry. And the molecular geometry really shows the shape of the molecule. In the 3D. And this is important to know because we need to know how it's going to behave in the 3D. Because chemical reactions don't happen in two dimensions, they happen in 3 dimensions. So as soon as you have your electron geometry, then you can figure out the molecular shape. And we do this by looking at the number of electron regions and then seeing how many of those regions are lone pairs. So if you have 4 bonded electron regions, meaning you have 4 atoms bonded to your central atom, then the shape is going to be the same as the molecular geometry. If you start adding lone pairs, then the shape is going to be different. Again, you will be given this table on a quiz. You do not need to memorize it. However, you do need to know how to use it. If you have 3 electron regions, no lone pairs, again, you're going to have a trigonal planar shape. The electron geometry and molecular geometry will always be the same if you only have bonded atoms to your central atom. As soon as you start getting those lone pairs on there, then the molecular geometry will not be the same. So let's look at some examples. We already drew the Lewis structures for our previous in for these problems. So if you need to, you can go back in your lecture slides and copy them down, or you can just use the ones here. So let's look at all of these different problems and figure out the molecular geometry. Actually, I did that in the wrong order. The electron pair geometry, the molecular geometry, and then the bond angle. The first thing you need to do when you are figuring out the electron and molecular geometry is figure out how many electron regions you have within your molecule. With methane, CH4, this is my C, and I have something on each side of my atom. I have something coming off of each side. So that means I have 4 electron regions. If I look at my table, my 4 electron regions is going to be tetrahedral. In methane, I don't have any lone pairs. If you don't have any lone pairs, then the electron geometry and the molecular geometry are going to be the same. You can also use your table to determine the bond angle for a tetrahedral molecule is going to be 109.5. In our next example, what I see happen a lot is people will only count the bonding sites. But remember, it's any electron region. Lone pairs are electron regions again. And if you see, I have something on each side of my oxygen. It's taking up all 4 sides. So again, my electron pair geometry is tetrahedral. In this case, I don't have 4 bonded atoms. I have 2 lone pairs. So if we go to our table here, I can find I have 4 electron regions, 2 lone pairs, so my molecular geometry is bent. My bond angle, it's still tetrahedral, so my bond angle is still 109.5. All right, let's look at these examples here. In this first one, this is where you have to be very careful. My carbon has 2 double bonds around it, but each double bond only makes up 1 electron region. Notice I have something on 2 sides of my carbon. I don't have anything above and I don't have anything below. So I'm taking up 2 sides of my atom. I have 2 electron regions. So when I look at my table, we'll go back to it so we can see. I have 2 electron regions, something on each side of my atom, and it's going to be a linear shape. What I want to point out is there is no linear area right here. And that's because if you have lone pairs on your central atom, then it's not only going to have 2 things around it. So anytime you have something that is linear, it can only be linear. So my electron pair geometry is linear. My molecular geometry, I don't have any lone pairs. It is also going to be linear. And my bond angle is 180 degrees. All right, let's look at ammonia. How many sides of my atom are taken up? I have something on each side. So my electron pair geometry is going to be tetrahedral. When I look at my molecular geometry table, I can look at my electron regions of 4. With ammonia, I only have one lone pair. So I'm going to look at the electron region of 4 with one lone pair, and that will give me my molecular geometry. So my molecular geometry for ammonia is trigonal pyramidal. When your shape is trigonal pyramidal, it's very important that you don't just write trigonal. You have to include the word pyramidal as well. Since I have 4 things around my central atom, my bond angle is still going to be 109.5. All right, let's look at our following 2 examples. With carbonate, there's nothing written down here. I have nothing on this side of my atom. So I have 1, 2, 3 electron regions. And that means I am going to have, actually, we'll go back to the table. I have 3 electron regions. So my electron geometry is trigonal planar, and my bond angle is 120. Since I don't have any lone pairs, then my trigonal planar electron pair geometry is going to be the same as my molecular geometry. Just like before, this shape is trigonal planar, so you can't just put trigonal. If you just put trigonal, then you can't differentiate between trigonal planar or trigonal pyramidal. So make sure you use both words. The bond angle is 100 degrees. I hope you can see that these carbons in these 2 different atoms or these 2 different molecules look very similar. Notice we have 1 double bond and 2 single bonds. So everything is going to be the same. My electron pair geometry is going to be trigonal planar. My molecular geometry is trigonal planar. And my bond angle is going to be 120 degrees.